Yep. Yes. Yeah. I wasn't catfished, at least.
She drove with you?
Yeah.
Which is fun. All right, we're live. The 40th anniversary. Everyone, welcome to OWASP Oakland County. It's our second meeting. It's also part of misec, SouthFeild. So thanks SouthFeild for hosting us. So this is OWASP is a AppSec security development kind of related community that we have national presence in the States. We also have national presence. If you're not a member, check out owasp.org. We have meetings all throughout the state, so go ahead and check that out. We have some announcements. We have on May 11th, we have a resume workshop right here in Town Center's SouthFeild. Wine was experience in food experience. Yeah. Thanks for hosting us. We appreciate it as well. So not much else. It's Nolan with Kobernetes. Thanks, Nolan. Ready?
All right. So working? Good. All right, awesome. All right, so my presentation is about Kubernetes. Just a quick note, I have a link and a QR code. If anyone wants to download the presentation, feel free to, if you want to follow along. It is around 500 megs though, half a gigabyte, so it's kind of big. So, all right, let's get started. And also, if you have any questions after the fact, feel free to reach out. So yeah. All right, about me. I am a DevOps engineer out of the Monroe, Michigan area. I love to travel. I brew my own kombucha. I've been in CrossFit for around 2 years. All right, so what makes me qualified to talk about Kubernetes? I have around 4 years of Unix and Linux experience. I have production experience managing applications on Kubernetes. Went to KubeCon North America 2022 as a sponsor. And it's a conference focused entirely on Kubernetes. Last year it was hosted in Detroit. And am currently working on a bare metal Kubernetes offering for our public cloud. Also, if I'm too quiet, feel free to speak up. All right, so this is the agenda. I'm not going to go over it, but these are the things that I want to cover during my presentation. All right, so containers. A container is designed to be immutable. What is immutable? It's not persistent. So any changes that you make to a container during its lifetime will not exist in the event of a restart. You might be asking, why containers? Containers allow developers to focus on the applications and not the underlying hardware. Here's a quick diagram to show the difference between a virtual machine and a container. Now, why Kubernetes? Kubernetes is a platform to manage containers. There are alternatives such as Docker Swarm or ECS. ECS is Elastic Container Service by AWS. But the goal with Kubernetes is to streamline the management of containers because managing containers by hand can be cumbersome. And it allows developers and operators to save time in the management of containers. All right, so what makes Kubernetes special? It's declarative. So what does declarative mean? If you define a state that you want Kubernetes to handle, so in YAML is the language that you define state. You define what you want in Kubernetes, and Kubernetes will produce that state. Scalable, so if you want a web application, for example, a website, your website can only handle 100 users. Well, I want to scale that to handle 1,000 users. Kubernetes can do that for you. If you have a database that needs to handle more users, Kubernetes can scale out that as well. It's self-healing, so application fails to start. One of your nodes is struggling, Kubernetes monitors and self-heals itself, or self-heals the workloads, and also pushes those workloads to other nodes. Availability. So you want your web application running on US East, US West. Doesn't matter where your application runs. If there's problems with availability, Kubernetes can push those workloads over. Yeah.
Can you clarify what US East and West are?
Yeah, so generally, those are terms used by AWS. But if you have a location on the East Coast or the West Coast or wherever, Kubernetes can make that application highly available by pushing that same exact defined workload to that region. And Kubernetes is also consolidated. So if you want to incorporate your storage, load balancing, like PKI, so your SSL certs, if you want to use it for secrets management and monitoring, Kubernetes can also do that for you. All right, so let's go look at a 1,000-foot overview of what Kubernetes actually is. Everything in Kubernetes is a resource. What is a resource? A resource is an object within Kubernetes. You define a resource, and Kubernetes creates the resource for you. Resources within Kubernetes interact over the container network interface. So there are multiple container network interfaces that you can utilize, such as Flannel, Calico, and Cilium. Those are the top 3 currently. And so that provides IPs for containers on Kubernetes. All right, so a pod is a resource that encapsulates one or more containers that define an application. So if you look at your web app, your e-commerce app, anything, a pod can represent that. Now, what is a node? A node is an instance, whether that be physical on bare metal or virtual in a virtual machine, on which pods run. All right, so you have a worker node and a control node. Control node tells the worker node what to produce resource-wise. Worker nodes run containers, also pods. A pod contains one or more containers. All right, so onto container runtime. So running containers themselves. You need a container runtime to create and provision those containers and also manage the starting, stopping, destroying the life cycle of that container. It is a node-based service, so it's not running in a container. It's a service on the virtual machine or the operating system itself. So yeah, that's how you can create containers. All right, continuing this 1,000-foot overview. All right, control plane components. So the first control plane component is the API server. API server is there to facilitate any requests going in, and it responds back to the user depending on if a resource was created or not, updated, edited, any action that you're trying to perform against your cluster. It also speaks with all of these other components, such as the scheduler, controller manager, and etcd. It is also responsible for maintaining state with your workers. So once the request hits the API server, it creates the resource, and the scheduler is there to find a node for that job to run on. So I want to create a pod, and I need a node to run that pod on. Scheduler does that, reports back to the API server, resources created. All of the components running Kubernetes themselves rely on controller manager to constantly monitor whether or not the cluster is healthy. If something changes, it will talk to the API server and reconcile that change. All of this state, the configuration that you're making, these changes that you're making to Kubernetes need to be stored somewhere in the event of a failure of your API server or any of these. So etcd is used to maintain the state of your cluster. etcd is a key value store. Think of it as a database used to store cluster configuration, metadata, and state. All right, data plane components. So data plane is where the workers live. Data plane components, kubelet is a node-based service. So kubelet sits in front of the container runtime, creating containers, managing containers, and kube API server to handle those requests. Once a container is created, it responds back to kube API, hey, I did this. Kube proxy is there to facilitate the connections between containers and kube API server. And if an outside request wants to reach that workload, kube proxy is there to also facilitate that. All right, so let's visualize this because I just talked a lot and that doesn't really tell you much about what Kubernetes actually looks like. So yeah, you have your control plane. Let's see if this works. Yeah, all requests flowing into the API server. Something changes, controller manager notices a state change, API server. As you can see, a lot relies on the API server instance, and so anytime you do make changes to it, you have to be very careful because that is in charge of managing your cluster. So yeah, that is this slide. All right, you're now an expert. You know everything there is to know.
Yeah.
All right, not really. All right, so how are containers implemented? You gotta start with a standard. So Open Container Initiative is the governing board for how containers and container images are implemented and how their life cycle is maintained. All right, so now we have a standard. We need a library to implement that standard. Runc is the library developed by OCI, so Open Container Initiative, and it implements that runtime specification. Runc was formerly libcontainer, which was donated by Docker to the Open Container Initiative. All right, and then on to container runtimes. So there are several container runtimes. The most popular, Containerd, Cryo, and Docker Engine. Docker Engine is generally used on your local dev machine. It's multi-platform. It's likely what most people are familiar with. So we started running applications on bare metal originally, and then we moved these applications to virtual machines. And you can think about containers as the next evolution of that. All right, so on to networking resources. How do I get traffic into the cluster and reaching my workload? Services sit in between endpoints and provide load balancing between the pods. So what that means is you define an object such as a service and you say, hey, this service is supposed to serve this application. And it exposes those pods. An endpoint object holds those IP addresses and ports. So when a service is trying to reach a pod, it looks at the endpoint object and knows, where do I send this traffic to? Sitting on the outside of this is an ingress. An ingress is holding the fully qualified domain name. So whatever your website is, for me, it'd be nhlabs.org. And then also the path routing. So if I want to go to a /status page, that it would send it to a specific service. And I have a diagram of this next. All right, so you have traffic coming in. So user is reaching your website. They're wanting to go to your website and they're going to the hello world. They type in example.com /hello world, and they're going to get sent to the hello world service. Inside of that service, or the service is going to look at a endpoint object containing the IPs and port numbers of that pod. If I go to another path, such as hello universe, same process. This is path-based routing. If I have a path that I've defined, there's a service associated to it. Also, the ingress controls TLS. So if I want to have my website served over HTTPS, ingress is responsible for that. All right, onto runtime resources. This is the heavy hitter. This is how your application runs on Kubernetes. All right, so you start with a pod. Just to reiterate, a pod is one or more containers defining your application. So you have a web app, maybe that's your web server, your database, maybe a PHP application running. Then now that you have this pod running your web app, you need to scale that out to more users. Generally speaking, if it's a web app that doesn't need or is not saving too much data, it's just serving content, you can use a deployment. And a deployment will ensure that you have a certain amount of pods running at all times to handle those requests. Daemon sets. So every single node in your cluster is running workloads, but what if you want to have the same workload running on every single node at a time? There's common use cases for this. So for monitoring, if you want to collect logs, do log aggregation on the host itself, if you want to implement a storage layer such as Ceph, which is distributed storage, or you want to logging, monitoring, storage, those are really common use cases for daemon sets where you want to have the same application running on all of your nodes. Now, onto a job. A job is just a pod. It executes a task, and it's not a service. So runs to completion, it's done. It doesn't need to keep continuously run. And a cron job is a job that is scheduled to run at certain times that you specify. You might be familiar with scheduled tasks if you work in the world of Windows. In the world of Linux, a cron job is just a time-based scheduled task. All right, so now onto configuration resources. There are two objects within Kubernetes for configuration. There's a config map and a secret. Config map is one or more key value pairs. Generally speaking, secrets are encoded, config maps are not encoded. So there's different use cases for how you want to use these. There's a reason that they're separate objects though. I'll explain in a bit. So creating a secret in Kubernetes. Yeah. I will explain kubectl in a minute. Think of it as the operator's tool to interact with Kubernetes. kubectl create generic, which is just a generic key value or key value secret from literal, which is my key is password, or yeah, key is password, value is bleat speak password. I grab my secret and I use JQ. JQ, if you're not familiar, is a way to parse JSON. JSON is just the format that I have it outputted to. If you see in this example, this is base64 encoded. I can use a handy little utility base64-d to decode that. So it's not encrypted. These are easily accessible, so you need to have proper role-based access control in place to keep these secrets safe. All right, what about stateful data? Some applications need to survive. In the event of a restart, termination, anything, a node dies, that's when you need to worry about stateful data. Generally, with virtual machines, you can patch, upgrade, replace. With pods, it is always generally replacing. In this case, you need to use persistent storage to keep that data safe. And with stateful sets, which is another runtime, similar to deployments, you're running pods, you specify a number of pods that you want to run, and they provide unique network identifiers. They give you unique names, so they're not just randomly named like a deployment would be. But they also factor in application availability. So if you're running an application on one node, or you have three pods, and those 3 pods are all running on one node, and that node goes down, well, there goes your application. Stateful sets work a little bit differently. They take that into consideration. So they will spread your application out across the cluster to ensure that it's always available. All right, DNS. DNS is a big topic in Kubernetes. Generally speaking, DNS is how applications within Kubernetes talk to each other. If a pod gets terminated, it gets a new IP address. And so how do I know what the new pod that just spun up is? I'll rely on internal DNS within Kubernetes. So an example that I have is you have a web app and a database. And the web app needs to talk to the database, and it'll use DNS. So it's my database.cluster.local is the DNS address. And I terminate that database pod. Now I don't have the database pod anymore. I need to look up and see what the IP of that database pod is. So Kubernetes relies on DNS heavily to maintain state. And core DNS is generally the application used to provide DNS for Kubernetes. All right, onto kubectl. So kubectl, if I'm an operator and I want to manage my cluster, I'll use kubectl to interface with the kube API server. I will use commands such as kubectl get all, and it'll request that from the kube API server. Kube API server will respond and provide this output. If you're wanting to create resources within Kubernetes, this is the general tool that you'll want to use. All right, so on to extendability. So how do I extend Kubernetes past its default configuration? You can use Lens. Lens is a graphical utility to visualize your cluster and all the resources running inside of it. So you have your applications, you can see deployments, daemon sets, stateful sets, all of that within Lens, and you can also manage it. kubectl crew is a plugin framework for kubectl. So if you want added functionality to that command line utility, you can use kubectl crew. Helm is an application repository. So what does that mean? If I have a predefined application such as a WordPress website or just anything, I can upload a template to the Helm repository. People can use that template to spin up the same exact configuration that I have. And it saves time writing these manifests for Kubernetes. And then also, Kubernetes can be version controlled. Two common utilities, Flux and Argo CD. Generally, those are the more popular ones. But if you want to version control your cluster for reasons of, I don't want anyone touching this but my version control. So you commit something to GitHub, GitLab, and that change is propagated down to your cluster, so you never have to touch kubectl. Onto common security mistakes. So the API server, users using privileged access to access kube API. How do I solve this? I use role-based access control. So the minute you deploy a cluster in production, you generally want to implement role-based access control to ensure that users are not using default credentials, because the default credentials have all the power. Common security mistakes, part 2, networking policies. So by default, all traffic is allowed. Any application running on your cluster can talk to any application. There is no rules in place to define the flow of traffic. And so if one of your applications gets compromised, that compromised application can talk to another application and cause havoc. So generally, you want to add network policies in place to define the flow of traffic and also isolate certain Kubernetes resources. So if your application doesn't need DNS or Kubernetes DNS, why give it? If your application doesn't need internal kube API server access, you don't need to give that either. And so also, Kubernetes automatically provisions tokens for each of these pods. And so if a pod wants, yes?
Oh, sorry, I was going to let you finish your thought there.
Oh, yeah. So yeah, Kubernetes automatically provisions tokens, so pods can authenticate internally. Yeah.
or easy is that to set up network policies?
Generally, network policies, there are default policies you can put in place. So you can do a default deny, and then you can, from your default deny, you can add allow or allowed entries. So my recommendation would be add your default deny, and then only allow the specific traffic that you need to be accessed. So external resource hits your cluster, it has a predefined path, can't go anywhere else. It's easy, but there are also some resources that can help you, and I have those listed. So it's just a couple slides. All right, so on to some demos. You don't need to truly understand everything that is going on here, but I want to show how easy it is to set up Kubernetes from scratch. So this is going through and installing a full Kubernetes cluster using kubeadm on a remote server. And that's just me saying hello from the remote server. And I'm going through and installing prereqs. So the prereqs are there to help the container runtime actually run, or those are there for the container runtime. In this case, I'm installing containerd as my runtime. So it'll go through, install containerd, and there are some changes it needs to make to the system to allow this container runtime to run, such as updating the configuration of that runtime, which I'm doing here. And now I am going through and installing the Kubernetes packages on this system. That also, while installing Kubernetes packages, installs some tools to manage my container runtime in the event I need to debug. The version of Kubernetes I'm using here is 1.25.8. The current release is 1.25.7, so things iterate very fast within Kubernetes. And you don't need to know any of this. I can also share out the script as well, if anyone's interested, to perform a Kubernetes install on Ubuntu. This is the system I'm doing it on. All right, and also, one thing to note, if you're installing Kubernetes in production, you want to set your packages to hold. What does that mean? My system can't automatically update my packages. So if there's a new version of Kubernetes and I have automatic upgrades happening, I don't want these to be upgraded automatically. I want to control that myself. So now it's going through, it's pulling images. This takes a minute. There are repositories for these images. So once this goes through, it'll start bootstrapping the cluster. Bootstrapping the cluster is creating certs, so it's adding TLS to the cluster. So all of these components communicate over TLS. They're not using insecure methods. Generally, this doesn't take super long. So now Kubernetes is spinning up the Kube API server, the scheduler, the controller manager. When it says, I'm waiting for kubelet to boot up the control plane, that's what it's waiting on. Creates your role-based access control. I'm also installing a CNI plugin as well, showing the control plane components running. And as you can see, they're not ready yet, but they will be. Give it, I don't know, 10 seconds, and all of these containers will be spun up, and you'll have a fully running cluster. All right, so if you see a status ready, I can point to it. And if you can see, that took me about 2 minutes and 30 seconds. And this was not the most powerful virtual machine out there. So this can be done way faster. So yeah, that is installing Kubernetes or setting up a control plane. All right, so in this demo, just to preface, I am setting up a web server with one pod and 2 containers. The first container is serving web content. So I'm going to reach this web server. I want to pull content from it. The second container is there to populate that content in the first place, and then also show me the logs of the content. And since it's in the same pod, I can reach that resource. So, all right, so I'm labeling my pod multi-pod as the name. I have which is a server. That is the first container. It is exposing port 80. And I have 2 volumes mounted. So these 2 containers are sharing the same mounts or the same storage. I'm also limiting the amount of CPU and memory that that container can consume. And then also I am saving to a file, well, before it goes, but I am saving a message to a file, and you will see that message. So it may not be as important right now. So I am creating that resource, creating that pod on Kubernetes. And you can see the pod status is not ready yet. Well, I can use the -- watch, which is a flag to just continuously watch every 2 seconds to see the status of your pod. It can be used for other resources as well, such as daemon sets, deployments, stateful sets. All right, so now I want to see logs from that pod. I can use the flag -- all containers to see logs from all the containers. And now I want to get a shell on that pod. So I want to actually enter the pod and start using it, similar to logging into a server. Start up a shell. And you might have missed it, but on the second pod, I mounted a logs directory, and that logs directory is shared between the web server and the second, or in this second container. So you can see 2 processes were started up by the web server. Oh, it looks like that's covering it a little bit. And so in that logs directory shared by the web server and this sidecar container, you can see access and error log, which is created by the web server. And so this command, you can't see it, but what's happening here is I am initiating a request to that container to get that message that I created in the first place. So if you were to go to that website in your browser, you get that exact same message. Now on that second container, I am looking at the logs from the web server without actually having to log in to the web server. And now I'm going through and deleting these resources. So kubectl delete, and that file I initially used to create. I'm using the -- force. Generally speaking, don't use that, but it makes it go faster for this case. But resources can stay running indefinitely. So yeah, if you see it, there's no more pods left. So that is a web server running with a sidecar container showing the functionality of that web server. All right, so where do you begin your journey in learning Kubernetes? I have some free resources listed. Killer Coda, I believe, is the name. They have some really nice labs for Kubernetes. They're all accessible. They're easy to use. They boot up in 2 seconds. There's also the Kubernetes docs. They have tutorials of self-paced labs. So if you want to set up, I believe they have set up this PHP app, and it'll walk you through doing that using Kubernetes. And now onto some paid resources. So I've used Killer SH extensively. That is the Kubernetes exam simulator. So for me to get my certifications, I use Killer SH to practice. It is very similar to the Kubernetes certified exams, but it also gives you a full environment to test and learn off of. I also highly recommend A Cloud Guru. It is paid, but William Boyd's Kubernetes content is highly recommended if you get a chance. All right, so you want to run Kubernetes. You don't need anything fancy to run Kubernetes. You can run it on your laptop, desktop, anything, as long as you have one of these components installed. You can use Docker Desktop. That is multi-platform. So if you run Windows, that is the preferred way to do it. It also runs on macOS, Linux. And then there's Kind Kubernetes. So if you look up Kind, it is a customizable version of Docker Desktop. I put that as like a medium scale so you can customize how your cluster looks. And then there's Kubernetes the hard way. I've done Kubernetes the hard way. I don't recommend it for beginners. I'm prefacing, like, do the other two first. Yeah, so that is setting up Kubernetes from scratch. You do not get to use kubeadm to just run a command and do it for you, like I showed. It would take a lot longer than 2 minutes and 30 seconds. So,
How long?
I don't know.
How many hours of suffering?
Well,
Are you?
I've done Kubernetes the hard way. It's not fun.
yeah, for me, it took about an hour and 30 minutes to go through it.
Okay, slices out.
All right, so my recommendation is to create a simple Hello World web server. Use Nginx, use Apache, use any container or any web server container and Dockerize it. Learn to Dockerize it. Use Docker files. Create an image and push it to a registry. Docker Hub's a really good registry to use for beginners. Trying to think of what else I would recommend. That's open source. Google Cloud, GCR, yeah. Docker Hub, just use Docker Hub. And then try to deploy that image on Kubernetes and access it outside of the cluster. And also, you don't have to push it to a registry. You don't have to create that image and push it to a registry. You can store it locally. Once you create an image on your system, it's stored in your local registry. All right, so on to questions. Feedback, tell me it's terrible.
What are some applications that like we use in our daily lives that we might not know run on Kubernetes? Like what are some big names out there that are actively using this technology to scale?
Apple.
Apple.
Does 95% of their workload on Kubernetes, we found out.
Yeah, anything that,
I know Netflix off the top of my head was a big one as well.
let me just say there's not really anything that you're currently hosting on a Linux/Unix server. There's I can't really even think of a situation where you wouldn't be able to run it on Kubernetes.
Any high volume shared resource would benefit from Kubernetes. It's basically the cloud, yeah.
It's the cloud. It's any big website that there's a lot of it.
Cloud is just somebody else's Kubernetes.
You talked earlier about the U.S. East to West Coast setup. In relation to Kubernetes pods, or just the system collectively, can you give a couple of examples as to why it would matter where you deploy that?
Yeah, absolutely. So I'm living in Michigan, and actually let me start over. I have two Kubernetes clusters. I have one that is based out of Monroe, Michigan, and I have one based out of California. And I have a client in Seattle that wants to reach my application. I'm not going to have them go all the way to Michigan to reach that application. I'd want them to go to the cluster in California. As long as the resources are replicated, or it could even be a single cluster as well. As long as your data plane is spread out enough, you can have that workload accessible to a user faster than having them go all the way to Michigan. So it's just proximity. It is.
So you're talking about shortest path.
Shortest path, yes.
Yeah. Are there any other reasons, especially, thanks for bringing up California because this is a good example. Is there any reason why I might want to have my stuff in California rather than Michigan, even if it's just for everybody to access? starts with an R.
Even if it's just for everyone to access.
Yeah, so I only have one of these pods. I only have one location where I'm running my stuff, but due to regulations,
Yes.
I might need to be in California, right? So California has significantly more stringent rules around various different types of content and how it's managed, right? So you might have to have your application stored there just to be able to comply with regulations.
Good. Yeah, I was not thinking about that actually. So yeah, thank you.
You spoke about DNS quite extensively, and before I go down this path, I just want to point out I really appreciate the level by which you delivered your content tonight. Kubernetes is not an easy thing. I think it's a very complex, even for somebody like me that's been in this for a while. I think it's a very complex thing, and I think you masterfully delivered your content tonight. I really do. In relation to what the DNS stuff you were referencing, if DNS became unavailable, could you still access that via IP?
Yes, because the endpoint is still there. So there are two objects. When you're accessing a service, the endpoint object, actually, let me rephrase this. I've had scenarios where if DNS goes down, you can't access resources. So it is a critical component, I would say. Unless your application is self-contained in a pod, then you wouldn't necessarily have to worry about that. But if your application is spread out across several pods, that is where DNS becomes more of a critical component.
When you say spread out, are you referencing load balancing?
No. So your application doesn't have to be contained in a single pod. Say, for example, you have in a simple web app, you have your web server and database. Those can be two separate pods. There's reasons for doing that because pods will share resources. And so maybe you don't want your database getting in the way of your web server. Also, distributing that workload, if you have a lot of that, or if you want to spread your workload across several nodes, you generally want to break those out into individual pods. So hopefully that answered. If not, feel free to correct me.
I'm sold, man. How much does it cost?
It's free. It's open source.
So free for all.
Yep.
Awesome.
You just spin it up on one of your 20% LG appliances.
It's free until you need to actually use it, then you need to pay a guy to actually configure it.
Yeah, keep me in business.
Or pay Google to host it.
And you have to pay him well.
I imagine Kubernetes does pay probably pretty good.
Any other questions? Critique? Anyone? All right, cool. So I will move on to some resources and references, the most valuable ones that I have.
You got us all.
What, you have a question?
No, we were about to start laughing.
I have a critique.
I was gonna try to like play the word like the end, but I couldn't.
You almost got me.
All right, so yeah, if you want to download the presentation, move my mouse out of there so you can scan it. But yeah, this is my presentation. So thank you.
Malware's in this QR.
It is half a gig, so like,
It's half a gig. That's a lot there.
and our company is hosting it, so
Android.
Please don't take out our video there.
yeah, he'll get paged if this takes it down. So yeah. Thanks all for showing up and watching my presentation.